Alright, welcome back. So I've got my testing there. Looks good. So this is going to be Apeman 2. Apeman is part of my involvement in codecartel.codes. So it's a collective of IT enthusiasts. And what we're focusing on right now is Micromanager. It's a tool that leverages AI to handle tedious software development duties, and then and then it can be used for so we're focusing on making it into a comprehensive code quality assurance tool. Um, so what I'm assigned to do is prompt engineering. So I'm going to start by reading this article here, which was sent to me by the leader behind Code Cartels. His name is Drew Brown. He should be well, there's no bio or anything, but it's here on Code Cartels, kind of so you can see his Bitbucket account. There might be, yeah. So if you click on him, he prefers to use Bitbucket. But anyways, really outgoing person. So if anyone, he might make a guest appearance on this channel at some point, and he's definitely able to be gotten a hold of. So, but for now, let's focus on this article. I think this will be really useful to a lot of people out there in YouTube. So, 5 things I wish I knew when I first learned programming. So, starting your programming journey is exciting, but it's easy to fall into traps that slow down your progress. By understanding the common mistakes new programmers make, you'll set yourself up for success right from the start. Here are 5 mistakes I made that you can learn from. And let's do a sanity check here and make sure that this person makes sense to take advice from. So it looks like he started his career in 2006. That's kind of a big year, 2006. That's when like YouTube first like started taking off and stuff. So that's a good year to start a career in computers for sure. He's been producing how-to content since 2018. Looks like his background is autodidactical rather than out of a university or anything like that. Then tech journalism. Let's see here. First tried Linux when he wanted. Okay. Okay. He's been using Linux for about 3 years now. Okay. All right. Well, this is a good one here. He's a student in information and communication technology, pursuing a bachelor's degree. So there you go. There's a university student that can help other people who are considering going to university for computer science or just tinkering around for the first time. And I'll add my own thoughts. I think my experience is a little bit more comprehensive. I've been using yeah. So and I'm older, so you know, but you know, so I'll add my own experience because I've worked a lot of jobs, contracts, and in a full hire for 6 years. So I have a lot of real world experience. I have a associate's degree, and I've been using technology for a long time as well. So let's not spend too much time on this and just try to get through. So the first uh, thing that would help to know before starting a career in programming would be number one, don't focus on the syntax, see the logic behind. When learning to program, it's natural to worry about getting the syntax right. The symbols, keywords, and structure of any language can feel intimidating at first, so you might wrongly focus primarily on memorizing syntax. However, this can be counterproductive, especially since syntax alone won't help you understand how or why code works. What truly matters in programming is logic, the process of breaking down problems into steps that can be executed by a computer. Syntax is simply a way to express that logic in a way the machine can interpret. Consider the classic beginning problem FizzBuzz. When trying to solve this, a syntax-focused beginner might get caught up in how to structure the if statements. When I was new to programming, I focused way too much on learning the syntax, especially the brackets, the semicolons, and the code structuring. As a result, when I tried to solve problems, I faced difficulty. Sure, I knew how to use conditionals and loops, but to actually use them to implement a solution was out of my league. Instead, it would have been more helpful for me to focus on the logic behind the solution. Understanding this logic means I could adapt this solution to Python, JavaScript, or any other language. In the real world, in real world programming, you often look up syntax nuances or library methods, even as an experienced developer. So my take on this would be, right from the beginning, get used to using something like an IDE, because that will help you with the syntax. That'll make the syntax happen automatically. By highlighting, and let's say we make a mistake here, we don't use this. We can see now this turned red, so that doesn't look good. It's red. Oh, there we go. Now it's back to yellow. So I would say that's my oops, and I'm gonna lose all my work here. So let me cancel this and shrink it down. So that would be my tip: is start using an IDE. Something like that will evaluate the syntax for you. Another thing is, I think it's called a static analyzer. So it's a tool that analyzes the source code without changing it. So if we look at a Python static analyzer, get a yeah, so you can also use a linter, so, things like that. So just get used to using those at the beginning. It's going to be annoying. It's going to clutter up the screen, but it'll put everything into this problems tab here if you're using this IDE. So let's say I get rid of this. Oops, I made a syntax error. Now it lists everything here for the file. It gives you the line that it happened on. It happened on line 1. And we can see the parenthesis was not closed. So yeah, instead of memorizing the syntax, get used to using tools and get used to get used to using tools. All right, and let's look up the FizzBuzz word game. Okay. Let's play the word game. Okay. Alright, so here's what I want you to do. I recently learned about a game FizzBuzz, Fizzbuzz. Have you heard of that game? Briefly tell me whether or not you've heard of that game.
Yes, I've heard of FizzBuzz. It's a classic programming challenge often used in coding interviews. The basic idea is to write a program that prints numbers but replaces multiples of 3 with fizz, multiples of 5 with buzz, and multiples of both with FizzBuzz. What's your interest in it?
Is it also a word game that you can just do, like, through speaking rather than just programming?
Yes, absolutely. FizzBuzz works great as a spoken word game too. Players take turns counting up from 1, but they say fizz instead of any number divisible by 3, buzz for numbers divisible by 5, and fizzbuzz for numbers divisible by both. If someone messes up, they're out and the game continues. Want to try a round?
Yeah, let's play that game together.
Great. I'll start and we'll take turns. Ready? 1,
2, 2,
fizz,
4,
buzz,
fizz,
6. Wait, I see what happened. Let's rewind. After fizz, it should have been 4, then buzz. Want to start over?
Well, you should have said 7.
Ah, you're right. Let's pick it back up. 7,
8,
fizz,
buzz,
11,
fizz,
fizz buzz. Let's keep it going. 14,
Wait, you said for 13 you said fizz buzz. That's incorrect.
oops, you're right. 13 should have just been 13. Let's correct that. 14,
Buzz.
15, fizz buzz. Let me know if you want to play again later.
All right, let's stop playing. I think I get how to play the game, but I feel like you're not an advanced enough player. Unfortunately, I'm sorry. I know it hurts to hear.
No worries, Graham. I appreciate the honesty. FizzBuzz isn't my strongest game, but hey, now you've got it down. If you ever want to challenge me again or need a new game idea, I'm here for it. What's next on your mind?
All right, so that was pretty cool, and you can imagine as the AI becomes more sophisticated, it can play this game at a high level. Imagine how helpful that would be for a child to learn like mental math and stuff like that. So yeah, exciting things to come. Assuming that can happen. I don't know, but all right. So the next thing this person which they knew before I started programming was instead of learning multiple languages, get good at one first. All right, so many beginners think that knowing multiple programming languages makes them better programmers, but in reality, depth of knowledge in one language is much more valuable than a shallow understanding of several. Switching from language to language without mastering any of them can lead to confusion and inefficiency. When you focus on a single language, you develop a strong foundation in essential programming concepts such as variables, loops, conditionals, functions, and object-oriented programming. These concepts are the core of programming, and once you grasp them deeply, you can apply them to any language with relative ease. Imagine you start with Python because it's beginner friendly and widely applicable in fields like web development, data science, and automation. By focusing exclusively on Python, you can become comfortable with core programming concepts and start building projects that reinforce these concepts. I started my programming journey with C. I soon got bored and moved to web programming. Then I saw the popularity of Python and started learning it. Ultimately, I couldn't learn any of them properly. At that time, I thought knowing several languages meant I could use all of them when I needed to. However, when it came to applying them, either I totally failed or wrote pretty bad code. That's because I didn't know the intermediate or advanced concepts of any language. So I have a story to tell, and I'm sorry, I won't name names. I won't even name where I heard this from. But a violin player who did not achieve a lot of success once said to me that they have basically mastered the violin. And, my response to that, I'm not a violin player, I'm a viola player. But it was like, oh, okay, well, I didn't laugh, which was good. But I'm like, oh, well, then about, and I started trying to have a more sophisticated conversation. And, it was Dunning-Kruger. This person didn't become that sophisticated of a player. So that's what I would say is like, be careful, in my own experience, be careful saying that you know a language until you actually know the language. So, like, you can't really say you're a network engineer, I would say, until you have a CCNA, ideally even more a CCNP, because that's the professional, right? Otherwise, you're just an associate. And a few years of experience. Uh, a network engineer is a very specific title, and it's not an engineering title. So you have to be honest, right? So I would say my advice would be honest. Like, you know, really get a sense of like who you actually are, what you can actually do, and don't disappoint anyone. Like, if someone reaches out to you and they're like, "Oh, perfect, this person bills himself as a Python programmer. We need a Python programmer." All right, well, can you solve this challenge in using Python? And you can't. You just never got that sophisticated. Like, all you can do on LeetCode is beginner problems, some intermediate problems. You can't do any advanced problems. You're kind of being dishonest, right? And worst case scenario, you don't even know you've never even heard anyone who actually is really sophisticated in these languages, and you legitimately think you've reached the top, even though that's probably cognitive dissonance, and that there are higher paid professionals out there with bigger titles doing more sophisticated projects. There are people with more academic background. There are PhDs. There are college professors. So, people say, for your own self-esteem, don't compare yourself to others. But I don't think that makes any sense. I think you do need to compare yourself to others, and you need to get a really good, confident sense of where you are. And if you're not happy with where you are, you got to move up, and that's going to be hard. The people at the top, they had certain advantages that helped them get there, but in the end, they put in the work. So, depending on your current circumstances, you might not be capable of getting to the very tip top, but if you know exactly where you are and you know exactly what the criteria is to get to that next step, you can make an assessment of whether or not that criteria is achievable. For example, this violinist who told me that they were a master of the violin was only in the second tier of the 4 tiers of orchestras at the time. So what this violinist could have done was looked at the audition criteria for the 3rd tier and really had a no-nonsense conversation. Can I play all of this material at a level high enough to play it better than other violinists at this top tier? Can I even like call up, try to make friends with the violinist and say like, hey, I'm working on this audition, and congratulations, you got into the next tier. Could you give me a lesson for how you, and just hear that person play? Because it might be a wake up call the other way, where like they're just not that good, and it's like, oh, okay, I just didn't get lucky, or I didn't, I had an off audition, I should do it again, and then I'll get in, because giving up is the surefire way not to move ahead. So that's my advice is really know where you are now and know what it takes to move up one increment. Don't worry about moving up to the very tip top 1% because it might not even be achievable for you depending on your people's success largely boils down to the area code they were born in. So you're not going to be the next Jeff Bezos overnight, but you could possibly, if you're a network engineer one at your company, you could possibly become a network engineer two if you are hyper aware of what the criteria for a network engineer two is, and you meet or exceed all of the criteria for that promotion. It is very likely that you could achieve that. So that's my advice is this idea of getting good at something. It's too vague. Be hyper aware of the criteria that you lack that would allow you to succeed one step up, not a million steps up to the CEO, and then have an honest conversation with yourself about whether or not it makes sense to work towards that criteria. So now sometimes taking one step up is a big leap. You'll have to go from a bachelor's to a master's to a PhD. So a real world gut check. Does this make sense? The answer might not be yes for that, but other things you just have to get a CCNA, and that's the only thing holding you back. Well, what is it, like $400 to take the CCNA? Another $100, $60 for CCNA books. Buy the book, read the book, do some active recall and some flashcards. Take your CCNA. Like, why wouldn't you do that for under $500 for probably under 3 months of your time? Like, if you're not willing to do that, you're not deserving of moving up. So that's what I would say for this is, yeah. Imagine you start with Python because it's beginner friendly and widely applicable. Okay, you're a Python person, right? Well, what does that mean? What did you do? Did you do projects? Did you get certifications? Did you work jobs? That's what I mean. Be really hyper aware of what the people one rung ahead of you are doing, and if you haven't done that, and you want to move up, do that. Please, now, do it. Do it tomorrow. And if you're happy where you are, then don't say you're like the best thing since sliced bread, because you're not. You haven't even done the criteria to move up one rung. And maybe it might not make sense for you to do that, but this is what I mean. It's like, be honest. Like don't say you're the best thing. You're a master of Python if you haven't even gotten a Python certification yet. The PCAP is, from what I understand, like the most popular one. You haven't built some significant project using Python. You haven't worked in a Python engineering job. You can't say you're a master of Python if you've just been learning Python for 5 years. It's like, what did you do with that Python? If you don't have a good answer to that, then you have to be honest that you still really haven't done anything that's sophisticated with Python. And then so you have to, if people are coming to you thinking that they're gonna get something and then they get something they weren't expecting that doesn't meet their expectations, you're gonna really that's gonna cause problems. So that's what I'm saying to avoid. All right, so let's go to the third one. Don't let tutorials tie you down. When starting to learn programming, it's easy to get drawn into the cycle of watching tutorials one after another, thinking you're making progress. But simply watching or following along doesn't build the skills you need to write your own code or solve real-world problems. This is what's commonly referred to as tutorial hell, where you keep consuming information without actually applying it. The reality is that programming is a practice-based skill. Just like you can't learn to play soccer by watching someone else play, you can't become a programmer without actually coding. Suppose you are learning Python and find a tutorial series that guides you through building an expense tracker. You code along with the instructor, and by the end of the video, you have a working calculator. It feels like progress. A big mistake I made was collecting different video tutorials, courses, blogs, and other resources and started binging them. I watched video after video, finished playlist after playlist, and only copied the code along the way. Since I only followed along, I struggled when asked to build an app or even a simple project from scratch. When you don't have to make decisions or face challenges on your own, you can't internalize the logic behind a project. Instead, after watching the first part of a tutorial, try to pause and build a simpler version of the project. Working through even a simplified version without direct instructions will help you understand how to structure and problem solve yourself. Yeah, I think that's a good one. Let's see here. So what I would say for this one as well is I think it's important to be able to read as well. If you're just watching videos, especially passively, it's not going to be as information dense as reading is. So you know, even tutorials, like if it's broken down and it's clear and everything, you know, things aren't going to be that way all the time. So watching like an entertaining video, I don't think goes as far as reading, and reading is the more commonly available medium. So that's what I would say. Don't let tutorials tie you down. I would say read, and then I would say break out of the box if the tutorial is very specific. Yeah, so yeah, I mean, general. This feels like it's really good advice, honestly. So I would say thumbs up to pretty much to what's written here. The only thing I would add is I think reading is kind of underrated. All right, so the next one is learn by doing. When it comes to programming, nothing beats learning by doing. Theoretical knowledge and passive learning can give you a foundational understanding, but only hands-on experience will solidify that knowledge and help you become a confident programmer. Project-based learning, where you actively create and build, will help you develop real-world programming skills. Projects can be as small as a to-do list app, a quiz app, or a simple game. Each project you attempt will introduce you to new challenges, forcing you to look up specific syntax or problem solve on the spot. By focusing on projects, you gain the confidence to solve real-world problems and begin to see yourself as an independent programmer, not just a tutorial follower. I once did an experiment. I wanted to learn PHP Laravel. Instead of consulting tutorials, I decided to work on a project from the start. I downloaded an open source project and started reading its code, tweaking it here and there to see the changes. It was a different approach to how people usually learn a language. Interestingly, I learned quite a lot in a short time. Soon I could write PHP code and make new features in a real project. So that's really good advice too. I will say though, you know, the tutorials and all that are better than doing nothing. So my advice here would be learn by doing, and make sure that you're doing rather than doing nothing. So even if it's a tutorial, that's better than just doing nothing. But yeah, this is good advice, I would say, to try to you know, jailbreak out of the tutorial and actually apply it to something meaningful. All right, so number 5, not knowing everything is okay. When you first start programming, it's easy to feel like you need to know everything. Every language feature, every framework, every tool out there. But trying to learn it all up front is overwhelming and unrealistic. Even the most experienced developers don't know everything, and that's completely fine. Programming is a constantly evolving field, and there will always be more to learn. Accepting this fact can take a huge weight off your shoulders and help you focus on making steady progress rather than trying to master it all at once. Programming involves a vast range of skills: syntax, algorithms, data structures, frameworks, debugging techniques, libraries, and more. Attempting to cover it all at once dilutes your focus and keeps you from gaining depth in any one area. This lack of depth makes it difficult to build projects or solve real problems because you're constantly jumping from one new topic to another without fully understanding any of them. In any case, I often overwhelmed myself by trying to comb through every topic in a programming language until I burned out. The more I tried to learn, the more I felt I knew nothing. A better approach is to focus on a few core skills and gradually expand your knowledge as you gain experience. Start with the basic concepts. Once you're comfortable, move on to slightly more advanced concepts. As you build projects, you'll naturally encounter new things to learn, but these will come in a context where they're useful. So, learning to program is a journey filled with challenges, and making mistakes is simply part of the process. Embrace these setbacks as an opportunities to grow, and remember that every expert was once a beginner too. Remember that each line of code you write brings you closer to becoming the programmer you want to be. Okay. So that's advice from him. Let's ask about this. Create for me a Mount Rushmore of computer programmers. All right, so Alan Turing, Grace Hooper, Cobol, Dennis Ritchie. So what do they have to say? Create a list for me of what they would likely say if you asked them 5 things they wish that they knew when they first learned programming. Okay, so this is ChatGPT, so you have to be yeah, so this is speculative. So Alan Turing, if he could rewrite this article, the number one would be that the theoretical understanding is powerful, but the practical application reveals unforeseen challenges. So basically the same thing the author said. The relationship between hardware and algorithms is as important as the algorithms themselves. That's a good one. You have to be aware of your hardware. That's a really good one. And I feel like when I was first starting, that's something I wish I knew too. Is like you're not going to train a large LLM if you're running a Raspberry Pi. You need a GPU. If I was more aware of that when I was first starting programming, it would have been so much easier to make progress, because it's like, why am I so bad at programming? Because your internet connection is coming through a soda straw. You can't pull down a Linux image. It takes you 3 hours just to download a Linux image. You need a reliable internet connection. Okay, so the third thing he would say is collaboration with others, even those outside your field, can lead to breakthroughs. That's a good one. Learning how to collaborate, that's a really good skill. I love that. The fourth one would be ethics in technology will become as significant as technical innovation. So that's a good one too, because there's kind of there's a wide net of different things you can do, and ethics is kind of a whole category that might that is available out there. And then the fifth thing he would say is the limits of computation are not as significant as the creativity of human problem solving. That's a good one. the yeah. So the more you, uh, yeah. So skill building really matters. All right. So the next person is Grace Hopper, and Grace Hopper um, developed the first compiler, which laid the groundwork for high-level programming languages. She was instrumental in the creation of COBOL, one of the first widely adopted programming languages. So, this was back in the era where women were programmers were mostly women. Because it was like replacing secretaries, right? So it's like it was like a tool where, like, you know, areas that were typically in spaces done primarily by women were some of the first to adopt computers, right? Am I just making that up? I don't know. Let's see here. So she was a naval officer, one of the first three modern programmers. Yeah, so this person definitely, I would say, belongs on the Mount Rushmore of computer programmers. So what is her advice for starting programming? First one would be debugging is as much an art as writing code. Anticipate errors and design for clarity. The next one would be programming languages will evolve dramatically, so focus on the principles rather than specific syntax. Number 3 is never underestimate the power of communication when explaining technical ideas to non-programmers. Number 4 is automating tasks saves not just time, but can redefine the limits of what's possible. Number 5 is the most innovative solutions often come from questioning the status quo. Oh, is this? I feel like this is the ask forgiveness lady. Is this the ask forgiveness lady? I know that there was someone, and I say lady, yeah, kind of a. There's someone that's like famous for that phrase, and that can basically be identified as the person who. Yeah. Oh yeah, it is. This is the person. Yeah, this is the person who made that phrase. Cool. Well, I love that phrase because it's like if you sit around all day waiting for permission for something, like you're wasting a lot of time and you're likely not to get it. Like, and you can say it's not only is it easier to ask for forgiveness than it is to get permission. It's easier to ask for awards, laurels, and praise than it is to get permission. Like, you know, if you do it right, you don't have to ask for forgiveness. It's like you did it, you know. Cool. So this is that person. I like that. Um, let's do the Wikipedia article. I typically like the Wikipedia article. Okay, Wikipedia is a good place to go still. So, um, huh. Well, I'm surprised that quote is not on here. Anyway, that's a good pick. So that's what she had to say. I'd say the one that stops off for me is this one that kind of ties into the ask for forgiveness rather than permission. And then this is a good one too. Focus on the principles rather than the and that's what it said in the article. All right, so then next one is Dennis Ritchie, and let's briefly see what he's famous for. Co-creator of C, key contributor to Unix, which is the proprietary precursor to Linux. And his work is basically persists throughout the development of all of this. So his advice is simplicity in design often leads to the most enduring systems. Think about portability easily. Software that works everywhere becomes invaluable. The tools and processes you use to write code matter as much as the code itself. Security concerns and programming will grow to be a major focus. Don't ignore them. Teaching and sharing your work can extend its influence far beyond what you do alone. And then, this is the guy. I think everyone knows who this is. So the strength of the project comes from the community around it. Engage others early. Version control is game changer. Invest time in learning and improving it. That's a good one too. Perfection is the enemy of progress. Build something functional and improve iteratively. That's a good one too. Open source is not just a philosophy, it's a practical way to achieve faster innovation. Your personality will share how you manage projects. Embrace who you are while striving to improve. Okay. Great. Now, based on this conversation, recommend for me 3 must-read books on the Libby app that are likely on that app that I can read. All right, and then we'll go to the Libby app. And we'll search for those books. So the first one is this. See if they have that. No results. Oh, here's one. So get a notification. And this is a vote that you want them to have this in their library. So I'm basically just voting for them to get it at a later date. So that's definitely worth doing. And then if they do decide to get it during the next cycle of when they decide what books are on here, I'll get a notification. All right. So same thing. So let's get a notification for the audiobook, and then also for the regular book. Perfect. And then we've got another one here. Another one. So I'm going to vote for the library getting that book, but they don't have it right now. Okay, unfortunately my library didn't have any of those. I'm in Austin, Texas. Can you recommend me some more? Which one do you think would be really likely that my library would have? Oh, yeah, my library has all of the 4 dummies. Oh, no it doesn't. I'll vote for them getting that. That's not necessarily the one I would want the most, but okay, don't have that one at all. Don't have that one at all either. Okay, so what we can do is we can search for these names in there. Now, Alan Turing is more of a historical figure, so all of his contributions would be likely under different names. So he would be referenced in the book, but he certainly wouldn't be. You know what? This looks interesting. I'm gonna place a hold on that. Oh, this is by Walter Isaacson. I'm a fan of Walter Isaacson. I'm gonna place a hold on this as well. Okay, so happy with that. Now let's search for Grace Hopper. Little Dreamers. Mind at Play. I'm a huge fan of Claude Shannon, and I'm kind of 2 degrees removed from Claude Shannon because I've met I don't think I made a good impression on him, but I met I don't think anyone makes a good, well, I've met Albert Lucas. I just like, I think I might have shaken his hand, but he went to the IJA actually this year from where this photo is from, and nobody kind of took him seriously because he was just like only about ring juggling. He doesn't know, I don't think he knows any side swap or anything, and he doesn't like pass or anything. So like in my circles in juggling, it was just kind of like, okay, here's this guy, like, yeah, it's cool that he can do 13 rings. It's cool that he was you know, kind of like performing with Liberace and like in Ice Capades and all that. But it's like what has he done lately, right? But it was I'm glad he was there. It definitely made the event special. I'm glad I got to meet him. One of his big I think somebody who really was a fan, like one of his big fans, somebody who really was impressed by his juggling, and really yeah, really a big fan of him is Claude Shannon, which is like, what? So yeah, so I'm gonna oh, I already have a hold on this. Okay, yeah, so I'll that's good. I want to hold on that. Then we'll search for Dennis Ritchie. Don't got it, nothing. And then we'll search for Linus. Ah, there we go. So we got a bunch of this looks like a good one. Leaders. Yeah, so I'll vote for the library having this one. I like this one too. Get in a month of lunches. I already know. I feel like I already know Get well enough. I'll vote for these. This one looks kind of interesting, so I'll vote for having that one at the library, and I'll vote for having this one at the library. And if they ever decide to do that, then they'll notify me. But unfortunately, as is, they don't have it. All right, so now next what we can do is we can go to the here we can do we can filter it out by those that are available now. We can filter it out by books or audiobooks. Let's filter it out by books for now. And then we can add more filters. So if we click that, we add more filters. So the audience, we definitely want to filter it out by the subject. So let's filter it out by nonfiction. So that leaves, okay. And then we'll filter it out by Um, Science would be a good one. Computer technology. So that leaves us with under 1,000 books. That's probably enough books to leaf through. So yeah, let's look like that because they're and we can filter it out even more. Let's get rid of the ones in other languages. And then let's focus on the Kindle ones too, because then that gets us to under 600, which is very doable. Okay, so now we've got 600 books that we can go through. Some of these aren't some of these are like biographies. But the Phoenix Project is up there. That's a good one. That's definitely a good one. When I was working at the internet service provider, that was actually assigned reading. So so yeah, some of these are probably fine. There really aren't any textbooks though. I wonder if I can filter out by textbooks. Or like O'Reilly Media. I mean, you'd need like I should get a subscription to O'Reilly Media. That would probably be good. How valuable do you think having a subscription to O'Reilly Media would be for me? Oh, really? Dang. Okay. That would be valuable. What about versus other learning platforms? Coursera, is that better? I feel like O'Reilly Media is more on topic though. Oh, Coursera is actually tied into universities though. And you can get degrees. Hmm. Pluralsight. Interesting. Oh, LinkedIn Learning's another one too. Khan Academy's free, but it doesn't go, yeah, beginners or students. Doesn't go hard enough. Alright. So these are all books I can just in one click get. Finding your voice, telling your story. Let me get this one because this my channel right now is garbage, so this might help. The Fourth Industrial Revolution. Let me get this one too. This looks interesting. Yeah, so my library has all of the huh. I'm gonna borrow this too because I like Ryan Holiday. I actually met him recently. I shook his hand. He was out on a jog, and I'm like, "Oh my God, it's Ryan Holiday!" And he's like, "Okay, great, yeah, go away. I have to go. I have to get back home and write another book." All right, so. All right. You are not a gadget. Oh, Jaron Lanier. I love Jaron Lanier. He's one of my favorite talking heads. I'm interested in this. So this is the idiot's guide to Raspberry Pi. Um, yeah, so let's do it for. You can create a Wi-Fi hotspot. LED light show. That'd be cool. Let me get that. Big book of dashboards. Mind change. Looks like a good one. And there's some good books with these filters on. Oh, I have to get this too. So they do have some O'Reilly media on here, but I have to get this one. Okay. Well, I don't want to spend all day browsing this. So far, we're at the hour mark of this video already, and all I've done was read one article that Drew sent me, and there are 2 other articles I would like to read as a part of this. So let's not spend all day on this. Yeah, let's not spend all day on this. So this is what I'm going to do is just close this tab as is. And then look at these other ones. So this is a big book of dashboards. Yeah, so let me get that one. That looks interesting. Mind change. Looks interesting. I'd be interested in how it touch tablets aid students with developmental disabilities, but this feels like more of a storybook, so I'm not gonna get that. This one looks amazing. Okay, so there we go. So let's go to the shelf, and now I've got all these books on my shelf. I've got let's see here. So here's my loans. I've got 6 loans. So these I can just access and start reading right now. Okay, and then I've got holds as well. I've got I think 6 holds as well. Yep. Perfect. So that's how you use your local library. Really great way to not only save money, but to focus your attention too, right? Because, like, you know, if every single book in the world is available to you right here, right now, which one do you read, right? So it's like, well, with the library, you read the one that's available right now to check out from the library. So, like, it can help narrow things down. All right. So I'm at a 1 hour mark. I finished reading this article. Next, I'm going to read the ocean prompting process. And then next I will read about reg, and then I'll do a bit more work, about an hour of work on Apeman, and then that will be it for this video. I'm gonna do the Pomodoro technique though, so I'll take a 15-minute break. We're at an hour here, and I'll be back soon. All right, so I took a bit longer of a break than I intended. I have one of my hobbies. I've got a kind of a deadline for that, so I've been putting some time into that, and then I got distracted talking to ChatGPT. I want to practice tempo modulation in music, which is speeding up and slowing down, accelerandos, decelerandos. So it's kind of hard to do that. There's really not a lot of good tools out there for that. There are some paid metronomes that have a tempo modulation feature, but I'd rather not pay, so I'm trying to get one for free. And I couldn't really find one, so the best way would be to use a Python script and just create my own metronome out of code, and then add a tempo modulation feature into that. Then I could practice tempo modulation, which would be awesome. It would really set me apart from other musicians, because a lot of people don't practice that, and it's a skill. It's something that shows up time and time again in music. It's a big part of music, so being able to practice that would be really cool. So yeah, I have to download 30 megabytes of an update to my C++ on my computer, and that's taking a while. I don't know why, because my internet is very fast, even though it's about half the speed that it would normally be. I don't know why it's so relatively slow. I'd like to put a wired connection in it. There we go. Now I've got a wired connection. We can see it's signaled there. So maybe this wired connection will help, although it's not updating. Yeah, okay, that helped. The wired connection really helped. Okay, great. So, yeah, maybe this will go faster, but right now that's just a distraction. So let's go back and make progress on the goals for this video. So the next goal for this video was to read this ocean prompting process, and then I just want to read this rag here. This might take too long, and then I do want to get into VS Code and work on this assignment. Let me start by reading that there, and then I should be able to make this video about 3 hours. So after another hour, I'll take a break for another 15 minutes is the goal, but I took a longer break than that. And let's put in another hour here. So ocean prompting process, how to get the results you want from an LLM, and most importantly, I'll do a sound check. There we go. Have you heard of ChatGPT, Gemini, or Claude, but haven't tried any of them yourself? Navigating the world of large language models, LLMs, might feel a bit daunting. However, with the right approach, these tools can quickly enhance your teaching and make classroom admin and planning easier and quicker. So I'm not sure what audience this is meant for. Let's take a look at the author. We want to make sure we're not reading something by like The Onion or something, a parody, or like a, not a real author. So this is so this author has written other things. It looks like they're writing a lot for kids, so I'm probably not the intended audience for it, but this is from the Raspberry Pi Foundation, which is a lot for computing education, as we see here for kids. So even though I might not be the direct audience, there might be some value in reading it as an adjacent audience. That's where the Ocean prompting process comes in. It's a straightforward framework designed to work with any LLM, helping you reliably get the results you want. The great thing about the Ocean process is that it takes the guesswork out of using LLMs. It helps you move past the blank page syndrome, the moment when you can ask the model anything but aren't sure where to start. I've never experienced that with LLMs. I just say, hey, what's up, and get it started that way. By focusing on clear objectives and guiding the model with the right context, you can generate content that is spot on for your needs every single time. So there are 5 ways to make LLMs work for you using the Ocean prompting process. Ocean's name is an acronym. Objective, context, examples, assess, negotiate. So let's begin at the top. Number 1, define your objective. Think of this as setting a clear goal for your interaction with the LLM. A well-defined objective ensures that the responses you get are focused and relevant. Maybe you need to draft an email to parents about an upcoming school event. Create a beginner's guide for a new Scratch project. Come up with engaging quiz questions for your next science lesson. By knowing exactly what you want, you can give the LLM clear directions to follow, turning a broad idea into a focused task. So let's see if I did that in my prompt that I did to try to practice tempo modulation using a tempo modulating metronome. So the first step would be to define my objective. So I think I did that because I defined the objective by starting the conversation by asking, is there a metronome that helps practice music that speeds up and slows down? And it said, yes, there are multiple kinds, but it didn't understand what I meant. It's saying that you can change, you can make gradual adjustments in speed. So you can practice at 100 beats per minute, then you can practice at 105, 110, 115, and so on. But that's not what I said. So I'm saying, sorry, you misunderstood what I was asking for. I don't want to practice at various constant speeds. I want to practice accelerandos and decelerandos. So I gave an example of that. You start at 100 beats per minute. You speed up till 40. I wanted to be able to practice speeding up and slowing down. So thanks for clarifying. What you're describing is tempo modulation. Smoothly and evenly over a section of music. So yeah, there are some tools for that. There are paid tools. A Soundbrenner metronome has a tempo modulation feature. The problem is it costs a lot of money. It costs probably, it costs, how much does it cost? A lot. It costs, so we've got an app, we've got a watch. That's interesting. We've got wave and monitors, a flow metronome. I don't know what this watch... Oh, this watch just has a bunch of music tools. That's kind of cool. I love that. So it comes with a tuner, a tracker, a vibrating metronome, so you feel the beat rather than just... Wow. That is cool. I kind of want that. Whoa. That is really cool. And can you practice tempo modulation with it? That is really cool. I really like this idea that you don't have to worry about hearing the metronome, because that's if anyone who's like really achieved a high level of musicianship should be able to tell you that when you're playing exactly right with the metronome, that something happens where like the sounds cancel each other out, and you can't hear the metronome. It just it blends in exactly with your note change, and it's they just blur together. For a long time, when I was younger, I would just think my metronomes like were broken, like they'd stop working, and it took me a while to realize like no, I'm just playing so perfectly along with the metronome that the sound of the metronome and the sound of my instrument blend into one source. Like they completely merge together. So like you have to basically hear your metronome through headphones, in order to actually like they have to be completely separate audio sources. Otherwise you'll stop being able to hear the metronome, which is like really disruptive. Like you want to hear both sounds, but you can't if you play them exactly together because they blend into just one sound. Which is what you want. You want it to blend into one sound. You want to play so perfectly together with other musicians that it blends into one sound. But when you're playing with a metronome, you don't want that, because then you can't hear the metronome. The goal of playing with a metronome is to hear the metronome. So when you play the moment you actually master playing along with a metronome is the moment you can't use a metronome anymore, because you can't hear the metronome. So I love this idea of just having a vibration, because you don't have to worry about hearing it. You're not gonna blast your ears with it. Oh man, you can hear your instrument better. I love that idea. Under 200, that's not too bad. But it's still a lot. Man, that's a revolutionary idea. Use gestures? What the hell is this? Oh, that's like a musical instrument. App doesn't look so good. Okay, so we've got a core and a pulse. Core 2 and the pulse. What's the difference between the... So the pulse has... Oh, you can see it. It's probably more expensive. Oh, no, it's less expensive. So... Yeah, it's a lot less expensive. Huh. Okay, so a pulse. What's the difference between the two? And sorry, I'm completely off track. I'm shopping right now. Shopping is not what I'm meant to be doing, but we can see we've got okay, it can just be a smartwatch. It has a decibel meter. It has a chromatic tuner. It has a practice tracker. Okay. I like how this one isn't also a smart watch. It doesn't distract you. So set up any rhythm, adapt to any piece, tap to go, twist to adjust. That's cool. But I want to know if you can practice tempo modulation with it. But even if you can't, that's pretty solid. Oh, and you can tap a rhythm? Oh, no. Oh, you can. You can just tap it on your... Oh, that's so cool. Wow. Oh, you have to tie it in with the app, though. Oh, you can strap it. You can feel it in your chest. Wow. That is really cool. This is really cool. Sorry, I'm completely distracted, but this is like really cool. I wouldn't get this one because I don't need an actual smartwatch. A decibel meter would be pretty cool. A tuner would be good to have, but I don't need like a tracker. I just need the metronome. The lights would be like kind of useful. Wow. Ah, yeah, okay. Well, the app is going to be really spammy and gross, so. Huh. Yeah, it's okay. It's the app is gross. I like the idea, but the app is gross, and I'm completely distracted here. So, let's keep going. So yeah, so this is the Ocean method of prompting. Um, so the first thing you do is to define your objective, and I'm going back. So yeah, I did that. So it now has a clear goal. So what's free? What are we talking about? Okay. Can't do it manually. It has to be all. So okay. So yeah. So now we're defining the objective more. I could just do it in Python. You can make a simple Python script for me that is a metronome that has tempo modulation. So it did that there. So the next thing is to provide some context. This is where you give the LLM the background information it needs to deliver the right kind of response. Think of it as setting the scene and providing some of the important information about why and for whom you are making the document or whatever you're trying to make. In my case, I'm trying to make a Python application that is a basic metronome that has advanced features like tempo modulation. You might include the length of the document you need, who your audience is, their age, profession, or interests, the tone or style you're after, whether it's formal, informal, or somewhere in between. All of this helps the LLM include the bigger picture in its analytics and tailor its responses to suit your needs. Okay, and then number 3 is few shot examples. Yeah, so they'll say that in there. So number 3 is include examples. By showing the LLM what you're aiming for, you make it easier for the model to deliver the kind of output you want. This is called one-shot, few-shot, or many-shot prompting, depending on how many examples you provide. Typically, few-shot is best. You can include URL links, upload documents and images. Some LLMs don't have this feature. Copy and paste other text examples into your prompting without any examples at all. Zero-shot prompting. You'll still get a response, but it might not be exactly what you had in mind. Providing examples is like giving a recipe to follow that includes pictures of the desired result rather than just vague instructions. It helps to ensure the final product comes out the way you want it. So that's OC. So O is in Ocean, it's an acronym. O stands for objective. C stands for context. E stands for examples. So next one is A. A stands for accessing. So accessing the LLM's response. This is where you check whether what you've got aligns with your original goal and meets your standards. Keep an eye out for hallucinations, incorrect information that's presented as fact, misunderstandings. Did the LLM interpret your request correctly? Bias. Make sure the output is fair and aligned with diversity and inclusion uh, principles. A good assessment ensures that the LLM's response is accurate and useful. Remember, LLMs don't make decisions, they just follow instructions, so it's up to you to guide them. This brings us neatly to the next step: negotiate the results. So yeah, like have a conversation, right? It's like, just like you would with a person, right? You wouldn't just accept whatever answer comes out with a person, and bias, especially if you're talking to someone that is not seeing it from other perspectives, you really have to overcome that bias to get to the right answer. So you can think of it almost like just talking to a person. It's not the exact right way, but it's close. All right, so number 5, negotiate the results. If the first response isn't quite right, don't worry. That's where negotiation comes in. You should give the LLM frank and clear feedback and tweak the output until it's just right. Don't worry, it doesn't have any feelings to be hurt. When you negotiate, tell the LLM if it made any mistakes and what you did and didn't like in the output. Tell it to add a bit at the end about, or stop using the word delve all the time. All right, so how to get the tone of the document just right. Another excellent tip is to use descriptions for the desired tone of the document in your negotiations with the LLM, such as make that output slightly more casual. In this way, you can guide the LLM to be approachable. The language will be warm and friendly, making the context welcoming and easy to understand. Casual, expect laid back, informal language that feels more like a chat than a formal document. Concise, the response will be brief and straight to the point, cutting out any fluff and focusing on the essentials. Conversational, the tone will be natural and relaxed, as if you're having a friendly conversation. Educational, the language will be clear and instructive with step-by-step explanations and helpful details. Formal, the response will be polished and professional, using structured language and avoiding slang. Professional, the tone will be businesslike and precise with industry-specific terms and a focus on clarity. Remember, LLMs have no idea what their output says or means. They are literally just very powerful autocomplete tools, just like those in text messaging apps. It's up to you, the human, to make sure they are on the right track. And I'm not sure if that's entirely true. I think some features beyond that can emerge, but I'd say it's mostly true. Don't forget the human edit. Even after you've refined the LLM's response, it's important to do a final human edit. This is your chance to make sure everything's perfect, checking for accuracy, clarity, and anything the LLM might have missed. LLMs are great tools, but they don't catch everything, so your final touch ensures the content is just right. At a certain point, it's also simpler and less time-consuming for you to alter individual words in the output, or use your unique expertise to massage the language for just the right tone and clarity, then going back to the LLM for further iteration. I think this should be THEN. Oh, no, it is a comparison. So at a certain point, it's also simpler and less consuming for you to alter individual words in the output rather than going back to the LLM for further iteration. Yeah, so that's a good point. Ultimately, if the output isn't exactly what you want, but it's close, it might be time to leave the LLM and just to go on your own. Like, for example, with it trying to set up a metronome for me, there might be a point where I would get to exactly what I'm looking for faster if I just am able to read and modify this code. Like a good example is, let's say that the duration is too long. It would be way easier to just know how to adjust this duration here to what I want, rather than to reprompt it and have it generate a new one that has the duration I want. And LLMs are non-deterministic, so if you have it keep regenerating the same script and you just want a small modification, it might start changing other parts that you don't want changed. Alright, so ready to dive in? Now it's time to put the Ocean process into action. Log into your preferred LLM platform, take a simple prompt you've used before, and see how the process improves the output. Then share your findings with your colleagues. This hands-on approach will help you see the difference the Ocean method can make. Sign up for a free account at one of these platforms. By embracing the Ocean prompting process, you can quickly and easily make LLMs a valuable part of your teaching toolkit. This process helps you get the most out of these powerful tools while keeping things ethical, fair, and effective. I'm kind of not sure why they keep coming back to this notion of keeping things ethical. Like, I don't understand how using the Ocean prompting technique would create a more ethical input and outputs. Like, you could use the Ocean technique to create unethical, unfair, and ineffective results from LLMs as well. So it's just kind of interjected in there in an awkward way, in my opinion. I think it's important, but I think I doubt that. I'm just not convinced that the Ocean method is the best way to keep things ethical. That seems very strange that they kind of wedged that in there. Oops, and I accidentally powered off my KVM. Hopefully that didn't affect the video. Just need to power it back on and it should be fine. Hopefully that's the idea anyway. Nope, that didn't work that way, so I'm gonna have to do something more comprehensive. Power it back on. Select the channel 1. Alright, so yeah, I completely worked it when I did that, so let's see if I can fix that. No, I completely worked it, so okay, there we go. So now I've got okay, so I've got output like that now. So now let's flip these around again. Oh, back in business, kind of, not really. Okay, back in business now. Although the resolution did change, which is unfortunate. Yeah, that's unfortunate. Anyway, let's just okay, so I'm still recording, so that's good. Let's just finish reading this. So okay, so by embracing the Ocean prompting process, you can quickly and easily make LLMs a valuable part of your teaching toolkit. Yeah. So if you're excited about using AI in your classroom preparation and want to build more confidence in integrating it responsibly, we've got great news for you. You can sign up for our totally free online course. Yeah, not going to do that. Yeah, not the best article in my opinion. It's just kind of a bit, I don't think it's that hard to prompt a LLM, and then I think constrained grammar free or what is it called? It's called I had this written down. Yeah, grammar. So I have it in the README for this. Oops. So So I should have it. Okay, so I can close this. I'm not sure if I need to save that. So let me just open a new one. So that's date time. Looks good. Yep, so let's change directory to Apeman. Okay, open it there. There, perfect. And now in the README, it's there. Yeah, so these are relevant concepts. So context-free grammar, I think, is more important to know about than that ocean method when it comes to prompting an LLM. It's basically an alternative to regular expressions. It's a yeah, so it's heady. It's difficult to apply. We've got math. We've got math. Uh-oh. Red alert, math. But it's I think gonna help a lot more with prompting than some, you know, acronym that doesn't actually mean anything. Okay, and then constrained decoding is another one. Another important. Yeah. Yeah, this article comes up a lot. I should read this article as well. In fact, let me do that. So after that article, you know, I only burnt up a half an hour on that. So with this second half an hour here before I take my break, let me read this one because I think this is going to be much more relevant to good prompt engineering than that ocean method. I just don't think that was that great of an article, to be honest. So let's do that. First, I'm gonna fix my problem here. There we go. Brilliant. All right, and then yeah, and then let's read this one. I think this is going to be a much better one. It's only a 14-minute read. I do need a quick break, so I will take that. Oh, and look at this. We've got this ready to go. So let me get kind of do these things in tandem. So this is for my metronome. So that's open here. So you've got to install C++ 4.0, which is here. So we'll do that and click install. So this is version, it needs to be beyond version 14. So I don't know what version this is. But we'll just hit install. Now it requires 6.9 of space, which is a lot of space. But let's do it. Oh, I should have clicked install while downloading, but okay, was happy with that. So there we go. We're setting that up. Okay, so yeah, let's dive into this. So this is a guide to structured generation using constrained decoding. This is the how, why, power, and pitfalls of constraining generative language model outputs. So introduction, we often want specific outputs when integrating with generative language models. This is especially true in programming domains, where a generated output may become a direct input to a function. Yeah, this is what we need. This is a key article. So good, I'm reading it here. But sometimes, no matter how explicit you are with your instructions, generative language models will get too creative, deviate off task, or simply succumb to their urge to yap, which is kind of a fun way to talk about. Oh, cool. So it's rude to put quit yapping in your custom instructions. That's funny. Fortunately, there are techniques to ensure language models only return outputs that conform to your requirements. This article serves as a practitioner's guide for perhaps the most powerful of these techniques, constrained decoding. We'll cover what structured generation and constrained decoding are, how they work, best practices, useful patterns, and pitfalls to avoid. So we've got a note to the reader. Let's start with that. This article is a living document being continuously updated as the field evolves. Terminologies such as structured generation and constrained decoding do not have consensus definitions, and their scopes are evolving over time. The discussion here reflects the author's perspective, and many differ from other contexts. So here we go. So let's do the. So that's the introduction. We finished that up. So next would be motivating example. I need a quick break. That's not my Pomodoro break, so I'll take that. All right, I'm back. So got more time in this. Oh, good. Okay, we're done. Oh, shoot. So it's recommended to reboot the system. Hopefully, I won't have to do that. So let's try this again. Simple audio. Good. Alright, so that just beeped one time. And then it looks like it crashed IPython. Unless there's like something to exit out. I don't think there is. So this play object wait done waits for it to finish. Then yeah, so there's nothing in there that should. Huh. Well, that's not good. It's not working. It's not working. It's exiting IPython. Do I have to run it as a script? It's not working. It beeps once and then exits IPython. Do I have to run it as a script? I can do that. Oh, I spelled it wrong. Nope, pade. Alright, let's see if that works. Nope. Alright, let's try it for 120 seconds, 2 minutes. Nope, just beeps once and exits. It doesn't work. It just beeps once and exits no matter what the settings are. It just doesn't work. Alright, maybe this is better. Nope, same thing. We'll try it with a higher duration. Nope. No, your changes still didn't work. It just beeps once and exits. It still doesn't work. The original script you gave me that uses, instead of using simple audio, it uses wind sound. WINSOUND. That one worked a lot better. Yeah, let's just use that. Yeah. Okay, let's see if this one's better. No, that's not working. No, that wasn't a rate of 100 beats per minute. No, that didn't work either. It made beeps that were faster than the rate of 100 beats per minute, and then the tempo didn't modulate. It might be because I need to restart my computer after the install of the C++ tools, but... Okay, well, you know what? I think that probably is the case, so I have, it's okay. I have it, saved, the one that uses the tools, so, so this will be, I'll test that once I restart the computer. For now, I can shift my focus back to not being off focus, so... Alright, so we're going to start with the motivating example. So to illustrate constrained decoding, we'll explore an example use case inspired by S.G. Lang's docs. We want to generate JSON outputs that represent Harry Potter characters according to the following schema. So the name of the character would be Harry Potter himself. He belongs to the House Gryffindor. His blood status, he's half blood, not a pure blood. And then his wand has a Hollywood. It has a phoenix feather core, and it's 11 inches long. So more context on this will follow, but for now, here's what this might look like without constrained decoding and other structured generation techniques using the SG Lang framework. Okay, so instead of that, we have like a Python script here. So we've got import SGLang as SGL. Then we've got a decorator here. A decorator is a function that takes a function as input. So we don't see where this is defined. Oh, we do actually. It's part of this SGL here. So SGL.function takes a function as input. So that function is provided below. So that's okay. So now of SGL, we're going to set the default backend. Then we're going to change the state using this here. Okay. and then we're going to print the state. So here's the character description based on JSON. Okay, we can see that the generative language model does a fine job of describing Hermione in JSON format. However, the JSON does not conform to our desired schema. It is also accompanied by unwanted commentary that makes this output inconvenient to parse for further processing. This article will demonstrate how constrained decoding avoids these issues. Okay. All right, so I guess we can feed this to the language model, and see if we get a similar example. Okay, so let's do that. So we want to generate. Yeah, so let's try that. Okay, so. Okay, paste that in there. Okay, now we're not gonna use this generations. We're gonna use this framework here. And we're gonna see, yep, and then we're gonna do it for Hermione Granger. Okay, and hopefully this will work. Okay. There we go. So, oh, look, we got it a lot better than they did in that example. So we've got the, yeah, we got it all the same, Wow, that's cool. Okay, but we can do better if we, yeah, so we can do better. So. All right, so what is structured generation? In the context of generative language models, structured generation encompasses a range of techniques that aim to generate outputs with a desired structure. Structured output could take any form depending on the user's requirements, but the archetypal example would be a JSON object with a specific schema. Another example of structured output could be strings that match a regex pattern, such as an email address, a telephone number, or even just a simple capital Y or capital N. Combining these ideas, a common structured generation goal could be to output a JSON object whose keys conform to a desired schema and whose values are consistent with expected data types, enumerations, and regex patterns. Another variation on structured generation are context-free grammars, which are used to generate outputs that follow sets of rules that ensure validity. For example, to form a working SQL query. Structured generation can be achieved in various ways, including number one, prompt design. The simplest approach is to include a description of the desired output structure inside the prompt. This could also involve few-shot prompting, whereby examples of inputs and outputs are included in the prompt. Number two, fine-tuning. A model can be subjected to further training for a specialized task using input-output pairs that demonstrate the desired output structure. This will incline the model to generate similarly shaped responses during inference. Number three, multi-stage prompting. Rather than have the model directly generate structured output, you can have the model respond to a series of prompts and then assemble the structured output yourself outside of the generative process. Number four, specialized services. OpenAI offers an optional JSON mode. Cool. that ensures API responses are returned as valid JSON, although it doesn't provide strong guarantees about the schema and contents of the JSON. So let's look at that briefly. So how to use JSON mode. OpenAI is becoming a Microsoft a Microsoft product. So this is all on the Microsoft help. Wonder if the settings, do the settings have JSON mode anywhere in it? Oh, that's cool. You can connect it to access. Oh, I like this. Oh, cool. I might need to do that. All right, so I don't see JSON mode there. I think I am gonna connect it to my Google Drive. Although I need to clean up my Google Drive a lot. It's a disaster. There we go. But I want to do that. Okay, perfect. So these techniques work with varying degrees of success depending on the difficulty of the task and the capability of the model. However, there's a more forceful method that can guarantee precise outputs, even when working with relatively weak models applied to complex tasks. Constrained decoding. What is constrained decoding and how does it work? In the context of structured generation, constrained decoding is a technique that manipulates a generative model's token generation process to contain its next token predictions to only tokens that do not violate the required output structure. Some of the art constrained decoding skips the parts of the structured output that are boilerplate scaffolding or tokens that can be uniquely determined based on preceding tokens and the constraints of the desired output. Only the parts of the output that strictly require generation are sampled from a restricted set of compatible tokens in the model's next token probability distribution. For a full exploration of the mechanics behind constrained decoding, I refer the reader to excellent articles and papers from the teams behind Outlines and SGLang. Constrained decoding is an area of active innovation that continues to benefit from increasingly effective optimizations. So this is good. So this is a full exploration of the mechanics. So this is the kind of thing I want it to be kind of a given that we at the very least have access to these. Perfect. And these are short too. Look at how easy these are to read. These are really small. All right, let me take a moment here, and I'll pull up my email. So I'm gonna pause and do this off camera. All right, I'm back. No longer in my personal email. So let's keep going. So I think these are going to be really key papers. So sent that out. Constrained decoding is an area of active innovation that continues to benefit from increasingly effective optimizations. Additional benefits of constrained decoding, as well as guaranteeing compliant outputs, the mechanics of constrained decoding outlined above can also reduce inference costs and improve throughput by, number one, increasing token generation speed. Constrained decoding simplifies the next token prediction space, accelerating generation, especially when implemented with clever optimizations that allow some token generation steps to be skipped outright. Oh, and this is the paper, so perfect. Number two, reducing the number of generated tokens. The throughput of text generation systems is almost always bottlenecked by the speed of token generation. And for many structured generation tasks, Much of the output is scaffolding that can bypass generation. For instance, a rigid JSON schema with fixed field definitions, we can save a lot of time by only generating the values and not the surrounding boilerplate. There's even precedent suggesting that constrained decoding can improve task performance. How to use constrained decoding. Constrained decoding is only compatible with generative language models that make their complete next token probability distribution available. For example, constrained decoding is only responsible for models run locally, not external APIs. Okay, so you can't use it with the API. External APIs may offer some structured generation functionality, such as OpenAI's JSON mode, but at the time of writing, I'm not aware that any support full-fledged constrained decoding. So that could be a big problem for some people. There are various frameworks that enable constrained decoding to be leveraged with local models, including SGLang outlines guidance and DSPY assertions. In this article, I elect to use SGLang, which builds on outlines under the hood to illustrate examples, although the same concepts apply across all frameworks. These frameworks are generally pretty agnostic towards the local model used and will usually be compatible with most popular models. In this article, any outputs that accompany the examples have been generated using Google/Gamma 2BIT, which is a model coming from Google. Yep. So Hugging Face is your one-stop shop for all things AI. It's the MySpace of the next super weapon to be developed, aside from nukes. So definitely, if you're into AI, you got to be active on Hugging Face. You should probably even have an account on there. So there are three main ways that a structured output can be defined for constrained decoding: regex, code, and generative constructs. So structured output using regex. Regular expressions, regex, are a powerful way to define structured output, as they offer maximum specificity over the format and contents. Here's how regex can be used in SGLang for constrained decoding. So we import SGLang as SGL. Character regex equals... okay, so now we're building a regex that is a JSON output. So we've got a raw string here. This looks like Python. And we do have escaped characters in the raw string, which is kind of interesting because I thought the whole point about raw string is you didn't have to use escape characters. So like, it seems like they want this to be a part of the ultimate output. And then even more interesting, they didn't use escape characters here. So I'm kind of confused why they used escape characters there in that way, and didn't use them in other places and made it a raw string. But anyways, the SGL.function, there we go, describe the character name. There we go, max tokens gives a limit. And the main downside of regex is that it's tedious to write and maintain, especially in the context of an active code base with an evolving data model. Another downside to regex in SGLang is that it introduces a considerable compilation time when installing run that is not encountered when using the specialized generative constructs. Depending on the framework, regex may produce different outputs to other generative methods due to algorithmic differences for token selection. More on this in the pitfalls section. Structured output as code. Structured output can also be defined as code using pydantic models. These can be dynamically converted into regex for constrained decoding. Using pydantic models like this is convenient as it ensures alignment between your application code and the constrained decoding process. To fully streamline your application, you can also use string interpolation to describe the desired output structure in your instruction prompt. This is a major benefit over alternative approaches where you may need to re-implement your data model in multiple places in multiple ways, risking code drift. Pydantic models can be used within SGLang like so. Okay. Now this is SGLang, which is kind of interesting. Let's open up my default WASL, which is Ubuntu. And then I've got this playground folder here where I can just mess around with stuff. So let's open up the... This is not the best way to do package management. The best way is UV. It's a package manager. So this is the best way. It's written in Rust. Rust is the absolute, you know, nerds are like really excited about Rust. Rust is gonna grow over time. Rust is right now it's not like popular, but that's probably one of the things that makes it good, right? It's like only the smartest, nerdiest people are using Rust right now. So like it's probably a good time to learn Rust. But yeah, UV is a fast modern package manager for Python written in Rust. So it's meant to be a drop-in replacement for pip, and it offers a lot of advantages. And the other thing with pip is that pip unfortunately it has some viruses as well. So like Torch, I think, is a big one. If you try to install PyTorch and you do Torch instead of PyTorch, Torch is a virus. So we can use yeah, let's create a virtual. So let's do deactivate to rm-rf venv, and then let's install pip. Let's install this into my virtual environment. Oh, sorry, into my global space using pip. So pip install uv. Yep. And then we'll create a virtual environment with uv rather than pip. Oh, okay. Well, it looks like that is a wrong. I think that's a AI. Oh, what? Okay, so those are just AI instructions. They're not real. So it got it wrong. That's not how you activate it either. We can see you activate it like this, just like you would activate it before if it was created in pip. But now we're no longer using pip. We're using UV, which, from what I understand, is better. So we can do UV. And kind of like a pip freeze. Oh, that's cool. You can do it. Oh, so basically, it's compatible with. You can use it as if you were using pip. Let's try that UV pip. Okay, and then. Oh, okay, yeah. So you can just do it like that. So UV pip freeze. Yeah. Okay. So UV pip Okay, yeah, I like that. Cool. So yeah, let's use that to get this this SG Lang. Yeah, yeah, yeah. Cool. I like that. And then let's do IPython. Got it. And let's try to put this code in there and get it to work. Okay. Oh. Isn't this a virus, though? Yeah, see, there's a yeah, virus total uh like PyTorch isn't a virus, but it's yeah. Huh. Yeah. Damn. All right. Well, I'm not going to do that cuz I think that's a virus. It's not a virus. It's PyTorch. That PyTorch is not a virus, but the somebody like yeah, it's a supply chain attack. Yeah. Well, that's not good. All right. Well, I'll skip that then. Oh, okay. So let me take okay, so I'm at the 2 hour mark, and so let me read down to here and then take a break. So defining structured output using pydantic models suffers from the same downsides as regex, as this is what they get converted into under the hood. What's more, the conversion process for complex pydantic models involving multiple levels of models can be unreliable or yield poorly constructed regex, often rendering this approach unviable in practice. Case in point, the above example does not actually work as the conversation is invalid, resulting in malformed inputs. This is a bug in the underlying outlines package, which will likely get resolved in SGLang soon. Okay, so I'll take my Pomodoro break and be back shortly. All right, I'm back. So mic check, 1, 2. close out this last hour here. So I might not get through everything I wanted to do. I wanted to finish another article beyond this. But let's close out this article. It hopefully shouldn't take that long. So the next section is structured output using interleaved generative constructs. The third option is to define your structured output as alternating static strings and generative constructs. This has the benefit of splitting out your data model into more manageable components where the generative parts of the task can be defined individually. In LangChain, the task performance of the gen constructs using functionality such as choices can be superior to their regex equivalents due to algorithmic differences in their implementations. More on this in the pitfalls section. The guidance package provides an illustrative example of this pattern. For our Harry Potter task, free text values for fields such as name can either be constrained by gen using regex or by using the stop mechanic to escape the token generation process. Without stop, the model would continue to predict the rest of the JSON without constraints. Here's how generative constructs can be used in SG Lang, not SS. So there we go. We import it, and then so now we've got. Let's take look for the stop here. So stop equals. Let's see where that's written in here. There it is. So this is the SQL.gen. There we go. So what you're doing is you're constraining it, and you're saying we only want it to generate the value. We only want it to generate this one thing here. We don't want it to generate the JSON syntax itself that we have here in a outside of the generation that we're asking. So don't generate any of the names of the keys. Don't generate any of the syntax just for the value of the key, which would be a name, a character from Harry Potter. We want you to generate that, but none of the other stuff. So you can see how valuable this would be, right? Because you don't want, because again, large language models are non-deterministic. So if you ask it a million times, 2 plus 2 plus 2 equals what? It's going to tell you 5. It's going to tell you 3. Most of the time, it'll probably tell you 4, but it's non-deterministic. So it's not going to give you the same answer over and over and over again. So when it comes to syntax, hard syntax that's the same and that's never going to change, you don't want that anywhere near the LLM because it's going to mess that up and then your application's going to get destroyed. You want the LLM to give you things that are going to be a little bit different every time, such as a variable. LLM would be great for that, but it's not great for things that always have to be exactly the same every time. And that's where this SGL comes in. So we can put this in outside of what we're asking the large language model to do. We're asking it to just generate these specific parts, and we can constrain it even further and say, not only do we only want you to generate the key here and not any of the syntax, not the value for the key here, not the key name, not any of the JSON syntax. We want you to generate based on these choices here, so you can constrain it down even further. And you can even provide it a regex, generate things that only fit this regex expression. So lots of power there. You can see how powerful that is. So depending on the framework and implementation, managing the scaffolding around the generative constructs can be syntactically awkward. In this SG Lang example, we rely on a finicky mix of single and triple quotes. We also have access to the final JSON output in a more opaque way via state.messages, open close paren, open bracket 1, close bracket, and then open bracket, double quote content, double quote close bracket, rather than this, as per the previous approaches, which is fragile when actively experimenting with the prompting strategy. Okay. Yeah, so character JSON equals state dot messages. Yeah, so state equals that dot run. There you go. Character JSON equals state dot messages one. There we go. So now we're not just calling the JSON that the LLM generates. We're calling a combination of the JSON of what the LLM generates and what we have statically outside of the LLM. So we're no longer asking for the LLM to write us a story. We're now playing Mad Libs with the LLM, and you could imagine, how much better it would be at writing a story if we write a really compelling story and then we just have it fill in some blanks in the story rather than having it make one up from scratch. We could write Shakespeare and just have it rename all the characters in Shakespeare, and we would have a Shakespeare play then, a valid Shakespeare play. Whereas if we said, write me a Shakespeare play, it may or may not be able to do that. And then, if we say it, act as Shakespeare and write me the next most famous play, it might not be able to do that as well as some of the greatest writers of our time, because it still lacks creativity and high order thinking and coherence in the way that organic human intelligences do. But you can integrate it. You can say, here's the parts of the story we absolutely have to have this way. But some of the stuff, character names, stuff like that, we don't really care. And then the thing is, like, let's say we want to write the story so that everyone around the world, finds it really compelling. So what we could do is we could write a story and then use this kind of approach to say, if I live in Austin, Texas, we're gonna use the large language model so that every character name, every like landmark we mention, every place we mention is going to be something you would personally recognize, because it's going to be generated from LLM based on your location. So you can write a story that's the same story, but you're using constrained decoding so that even though it's the same story, everyone around the world is really going to relate to it, because the story is going to be converted to their language. All the character names are going to be generated to be names that they're familiar with. If you're in the United States, John and Mary are familiar names. If you're not from the United States, those are going to be very odd sounding names. So you can have it create a book or a story where everything seems very relatable. If we talk about imagine that, like, there's a lot of potential here. What are the pitfalls? Imagine the model does not know the constraints in advance. Most constrained decoding pitfalls are due to misalignment between what the generative model wants to output and what the model is forced to output. The mechanics of next token prediction and constrained decoding are such that the model does not know what is coming in advance. It generates predictions only based on the tokens that precede it. This can result in poor performance if the model is forced to output something unnatural. For instance, in this example, we observe the unexpected behavior if the model is constrained to output country options that start with a lowercase letter. Yeah, so countries start with a capital letter, so it's going to have a harder time with lower cases than upper. So we can see here, we define which country, and isn't this cool? So the model's not gonna generate any of this. It's just gonna pick out a city name, and it's gonna use these choices here. So when we run that, yeah. So and then this is in lowercase, so we're having it here. So it's gonna have a harder time with unnatural formatting. The name of a country starts with a capital letter. The best way to mitigate this is to ensure the model understands the task and expectations by providing sufficient information in the prompt. If working with JSON, it's also worth considering the ordering of your schema fields and structuring them logically such that they're amenable to next token prediction. This may also include using descriptive field names and not constraining the model to esoteric field values. Inspecting the token probabilities is a useful debugging technique to identify cases where the model has been forced to output something with low confidence. With SGLang, you can retrieve the log probs for each choice option like this. So state.getMetaInfo house normalized language log probs. Okay, so beware greedy token selection. Another pitfall to be mindful of is how your constrained decoding is being implemented algorithmically. This will vary depending on the framework and constructs you're using. For instance, in SGLang, constrained decoding for a multiple choice string is different when configured as regex versus gen's choices argument. The former uses a greedy next token prediction, whereas the latter evaluates all options completely. Other libraries may use variations on beam search. We can see how this can go wrong in the following example. So here we go. So same thing, but now we're choosing a U.S. president. So name a U.S. president, and we've got this S here. So I guess that's the string we're gonna produce. So plus equals. So name a U.S. president. So this is the prompt we're giving the LLM. So it's gonna name one, and then it's gonna say. Yeah, so neither of these are U.S. presidents. So, huh? Okay. Huh. Okay, so the greedy algorithm used by the regex implementation is short-sighted and it cannot. Oh, okay. So it's always gonna choose Donald because there's never been a So yeah. So let's see here. So if we give them these options to name a U.S. president, and then we use the greedy yeah. So here's our regex. Interesting. Oh, right. So if you use regex rather than the choices argument, and we can see the choices argument. Yeah, see how this is? It's gen comma choices. So another thing you could do is regex, but you got to be careful in doing that because what happens is regex automatically uses greedy next token prediction, whereas choices evaluates all options completely. So what happens with the regex is once it finds a match, it goes with the first match. So it's kind of like reading a routing table in network engineering. It won't read any of the other options. So, it's gonna, an example of a U.S. president is, we've got so this one will work because it can choose between Donald Duck, or it can choose between Millard Fillmore, and it's generating an example because we're feeding it this prompt, and we're saying now we got to generate um, a president. So we're feeding it. Oh no, this isn't a prompt. I think this is the prompt. So president. The name of the U.S. president is President, and now you can choose between Donald Duck or Millard Fillmore. Neither are presidents. So I don't know what it would do in that case. It looks like it shows Millard Fillmore. That's kind of confusing. But this one here, it will only choose Donald Duck because Donald is the name of a U.S. president. So once it matches with that, that's it. There's no. It doesn't even matter if this said Abraham Lincoln here. It wouldn't even get there because it already matched and moved on. So you got to be careful to be aware of that, especially when you have to use regexes. If you don't have to use regexes, then you're better off using choices like that. The greedy algorithm used by the regex implementation is short-sighted and cannot resist choosing the Donald option, despite ultimately landing on an incorrect answer. The choices approach avoids this by evaluating the quality of all options in their entirety and not just based on the most attractive initial option. Oh, and by the way, this shows how much I know about history. Millard Fillmore is a U.S. president. He's the 13th U.S. president. What's the guy's name? There's a Disney character that like sounds like this name. Let me ask the ChatGPT. Is there like a Disney character or a cartoon character that has a name that sounds a little bit like the 13th U.S. president's name, Millard Fillmore? Theo Slash? What about like Elmer Fudd? Yeah, I think that's my brain kind of auto completed this to Elmore Fudd because there's a clear it's like ba 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 and then a big F sound. So my brain auto completed Millard Fillmore to Elmore Fudd, and because it said Donald Duck. Okay, this is interesting. So I'm reading through a thing, and what happened was. There was I was reading about greedy token selection, and to give an example of that, they had a large language model choose a U.S. president using a regex, and the regex had an or statement in it, and one of the options was Donald Duck, which is obviously not a valid option, and then the other option was Millard Fillmore, which obviously is a valid option. It's the 13th president. But as I was reading this, because I saw Donald Duck and I saw that it was a Disney character, somehow my brain like auto-completed Millard Fillmore to be like Elmer Fudd, because Millard and Elmer both have two syllables, and then there's that strong F. So like the rhythmic nature of both of those names kind of made it in my brain seem like it was Elmer Fudd, and like I actually kind of didn't realize that Millard Fillmore was a real president. Now my history knowledge is so lacking that even if I hadn't made that mistake, I'm not sure if I would have recognized Millard Fillmore as being a legitimate president. But is there like a psychological name for this, or is there like a technical jargon term for this sort of thing that like happened to me when I was reading this? Semantic priming. Yeah, that's what happened. Okay, because it's not strongly linked in my mind to U.S. president. Oh, yeah, there's a bunch of them. Cool. So semantic priming, phonological similarity effect, yeah, pattern completion, lexical inference, and the misattribution effect. So your brain tries to make sense of novel information by linking it to something already stored in memory. Lexical inference, the brain has overlapping storage for linguistic features, and less familiar words or concepts are more likely to be overridden by more familiar ones. Pattern completion, humans are wired to complete patterns, especially when a term doesn't immediately resonate. Phonological similarity effect. Your brain processes names by their syllable patterns, vowel sounds, and consonant stresses. And then semantic priming. Your brain tends to group similar concepts or categories when it encounters a lack of strong associations with one of the terms. Okay, so the greedy algorithm, yep, cannot resist that. The choices approach avoids this by evaluating the quality of all options in their entirety and not just based on the most attractive initial token. So what are some useful tips and patterns? How to generate a varying number of structured prompts. A tricky but not uncommon structured generation requirement is to generate 0, 1, or many outputs that adhere to constraints from a single input. Specifying such constraints in regex is sometimes theoretically possible, but usually ill-advised in practice for all but the most simple string patterns. A better approach is to use flow control to enable the model to generate multiple structured outputs in a series of responses. Here's a pattern for this in SGLang. So now we're using flow control. So this is cool. So the large language model doesn't have to generate the whole thing, and in fact things that we always want to be the same, we're not going to have it generate at all. And not only that, when we do ask it to generate something, we're going to constrain it even further and just have it pick from a series of choices. In addition to that, what we can do is this is interesting. Well, I don't know. Let's keep reading. Another strategy for generating one or many type outputs is to seed the first element in an array with constrained decoding, and then have an unconstrained generative function for subsequent elements with a suitable stop criterion. The assumption is that the model will be smart enough to continue the pattern established by the first element. This can work reliably for straightforward substructures, such as simple array fields within a larger JSON object. Alright, well, moving on. Post-processing of structured outputs. There are scenarios where you can achieve better task performance by defining intermediary structured outputs for constrained decoding, and then converting this to your final structured output during post-processing. This can be the case when using enumerations that the model handles poorly. This can be mitigated by temporarily adding more intuitive aliases. Here's a contrived example that would be better avoided using gens choices instead of regex. So you have to be careful using regexes. There are some times where it makes sense, but in places where, but basically anywhere you can, it's better to use the choices. Another case where post-processing can be useful is for JSON schemas that contain optional fields. Rather than using complex regex to specify the optional fields, it's usually easiest to include all fields in the structured output and have the generative model populate unneeded field values with placeholders. These fields can be deleted during post-processing, even for expansive JSON schemas with many optional fields. This is inexpensive with constrained decoding, as this JSON scaffolding does not actually get generated. Alright, so, so grass, and then we've got grass aliases, so grass, there we go. Colors, we got that, so we can see the difference. Oh, color, Okay, print state color gray, force green. Gray, gray, force green, green, force green. Huh. Interesting. Well, anyway, moving on. Advanced constrained decoding, context-free grammars. Context-free grammars, CFG, are a tool in computational linguistics for describing the syntax of languages. Simply put, CFGs define rule sets that specify how strings can be constructed. CFGs can be thought of as a more powerful and expressive form of regex that can handle complications like nested and recursive structures, and tasks like balancing parentheses. This makes CFGs a useful tool for complex structure generation tasks, such as elaborate JSON objects, that can bypass some of the hackery shown previously when working with simple generative constructs. SGLang does not support context-free grammars, but llama.cpp does. The code snippet below shows how an array of Harry Potter character JSON can be defined in llama CPP's required format, GBNF, a variant of Bacchus now form. So there we go. Okay. When we run, we can see that this can successfully handle generating one or many type outputs in a single conversation turn. Okay. If working with GBNF syntax doesn't appeal to you, Guidance is another good option that supports context-free grammars via a purely Pythonic interface, which should be nice. Alright, yeah, that would be nice. Guidance sounds good. Heck yeah, I'll star that. Alright, so conclusion. Constrained decoding is a powerful but underutilized technique for structured generation. It's a significant advantage that local models have over external APIs and can enable relatively small and inexpensive models to perform comparably to much larger alternatives. The throughput and latency improvements that constrained decoding provide can also be extremely compelling. In my experience, SGLang has particularly impressive backend optimizations that increases the speed of JSON generation by one order of magnitude versus unconstrained equivalents, whilst also guaranteed well-formatted outputs. So it's a win-win for using this. Not only are you more likely to get what you want, it goes faster because you're not feeding it. You're reducing the load, right? You're playing Mad Libs with it. So, you know, all it has to do is fill in the words rather than write the whole story. Great article. Yeah, this one was really good. It might be worth. Yeah, this is a really good article. So the whole blog is probably pretty damn good. So here's the author. So yeah, this whole blog is probably pretty darn good. Let me. Well, I'll just put it in the description for this video, and that'll be where it stays. Okay, so where does that take me? That takes me to the 39-minute mark. That's not quite the 3-hour mark. That would be a good time to take a break. So I definitely want to finish up this rag handbook, but this is going to be quite a bit. So this is just kind of a lot to do. All right, yeah, this is kind of a lot. It's a bit too much for tonight. Um, I'm not sure how much value there is to just read it out as well. It seems more like a reference sort of thing. Um, it has this, yeah, so it seems more like for reference than just reading out loud. But so you know what? I think I am gonna, you know, I think I will go ahead and just have that be for later. And yeah, I think I'm gonna end the video here. Actually, it's just you know, another 20 minutes on the clock would take me to an hour. That would be more Pomodoro as well. I'd be cutting my Pomodoro cycle short if I just stopped right here right now. So I can keep going. That's fine. Oh, you know what? Let me just put in some raw. Let me put in some raw time into this. This is meant to be a video on Apeman, so let me put in some raw time into 20 minutes of raw time into Apeman, and that will be that for the video. So let's take a look at the change I made to the README. I made one recently. So yeah, so. We got to start with we've got to include a SQL QA tool in what we start with, because that's absolutely critical. So I made that change. And then I also changed yeah, and that's the only change I made. All right. Okay, so yeah, let me put some more raw time into this. So we can see. So yeah, let's open the README again. Open the to open that. So okay. And let me make an edit here, because this, I don't like that. So to more about the micro manager project. Okay, clarified. So clarified what was meant this project. Okay. Alright, I like that a lot better. Now this is more, no, so it's not about writing a prompt. It's about, so it's about this use template, yeah. You've got to give it the station template. So you're not writing a prompt, you're writing a station template. So let me clarify that. Writing a template that can be used as a prompt. There we go. Train track. Yep, there we go. Okay, so goal, so there we go. So git add, git commit -m. Goal of Apeman isn't to write just any prompt for an LLM. It is important that the prompt contains train track code, train track template. Okay. So, okay. So goals of Apeman, starting with these and all their dependencies and plugins. Manually experiment with writing a train track template to be used as a prompt that provides an output from any LLM that successfully installs, configures, executes, consumes a QA tool configured to its highest code quality standards. The prompt must serve as a template with variables that can be filled in automatically to produce the same result for other QA tools. The result is a functional bash script produced from a generic template with variables filled in from a spreadsheet of QA tools. So the relevant things you might need to know for this are just general prompt engineering, but more specifically constrained decoding and context-free grammar. Constrained decoding, that was really key. So let me add this to that. How do I make something a hyperlink in Markdown? Okay, so there we go. Let's do that. So, constrained decoding. There we go. You put that like that, and then you go like this, and there we go. So components, we're gonna have the station template, which contains train track pseudocode, which contains variables to be. I'm gonna change that to be. Variables to be filled in by data from a spreadsheet. Installs converts to bash. Then we have mocker, which fills in the station template variables in a loop using the QA tools spreadsheet. Then we have QA tools spreadsheet, and that's the link for that. I can make that a little bit neater. Let's do that. All right, and then we have more notes. I think at some point I will get Drew here in this space, which is on my YouTube channel. I'll post it public for anyone to see, and he'll give me more clear instructions. I do need to find he says at this point confidentiality really doesn't matter. Which is nice because these YouTube videos help me focus. So let's do a get status, get add, and then we'll say small get commit the shim small grammar clarifications and hyperlinks. We'll just say that clarifications, hyperlinks, push. Okay. All right. All right, so that looks good. Yeah, so I've got basically got Mocker, I guess, to work in a sense, but again, you know, Drew wants things done in a specific way, so I don't know if this satisfies that. But we are able to go ahead and run Docker if I just go up to run here, and then I do Run without debugging. Oops. All right, let's try that one. All right, and then try this again. Run without debugging. Okay, that didn't work. Yeah, so disable that. I wondered if this was. No, this is .sh, so it's not C code, so that's not gonna work for that. Okay. All right, so we can run it. Let's forget about that. Let's just run it in the CLI. That's easier. So bash mocker. So there we go. Now we create all the templates. Generated templates here. So we've got one here, and now it's filled in. Okay. But we need to get so this is not complete. And this shouldn't really be called generated templates. We should be this should be prompts. This should be called prompts. Yeah, let's call it that instead, because that makes more sense. Okay. Yeah, so it's going to use the station template. But we want it to look like we want it to look like this. Yeah, use tool template. So this shouldn't be a station template. This should be a use template. So let's okay. So let's just add this. Okay. Okay, and then we'll call it yeah, so it's not a station template, it's a use tool template. But for now we'll just make this small change. We'll say git commit -m. Goal is to generate prompts to be fed to LLM, not just the filled in template. Oop, and I gotta spell commit right. So I have to include an I. And there's a git push. All right, so yeah, that looks good. That probably took me to the 3. Oh, not quite. Let me pause it and be back, and then try to close out those last 5 minutes. All right, I'm back for about another 5 minutes. So, yeah, let's run this. So bash mocker. There, that's a lot better. Now it's the prompts. So we'll have an actual. Yeah, so let's do a similar thing. That so we're gonna fill in the. Yeah, so check out the station template file exists. Yeah, and then there we go. And then let's do the same thing to fill in the prompt. So we can see in the station template we say use, and then we have this syntax here. And see how that fills that in. So we just need to add another entry here. It's going to be -e, and we're going to substitute. It's going to say prompt. And it's going to be prompt. Like that. Okay. And this needs to say prompt. There we go. And we can see tool equals the tool name. So now we can have the prompt be CSV file. The prompt would be filled in by yeah, so down here. Oh, we can have it up here. Yeah. Oh, here we go. This is interesting. I can just have the prompt actually in the... That's a better way to do it. Just have the prompt in the thing. So, yeah, we don't need this file at all. That's dumb. Yeah. Okay. Okay. All right. All right. So git commit dash m would be prompt can go. Okay. And that's it. So it takes me to 8 o'clock. We've got 3 hours out there. So yeah, unfortunately, I didn't get to the final article. I wanted to read more about RAG, but I think this was a good video. This constrained decoding, very powerful. So yeah, having this whole video basically devoted to that is a good thing. So that's it for this video. Thanks for watching. See you in the next one.